Welcome to the second video in this 4-video series about inverse trigonometric functions. Here we'll study what I call the other four: the inverse tangent, the inverse secant, the inverse cosecant, and the inverse cotangent. Here are the definitions, similar to the first two that we saw in the last video, for the other four inverse trigonometric functions. Now there's a lot to read here and it's not worth going over each one now. They all, to some extent, follow the same spirit of the last two problems that we saw in the previous video. So you may need to come back and review these definitions, but you may not to. You may not need to, because some of them are things that you would have thought of on your own, just getting the general idea of what an inverse trigonometric function is. But there they are. So we're going to do two examples here. One of them is going to be an inverse cosecant. Suppose we wanted to find the inverse cosecant of radical 2. Well, here's the definition of inverse cosecant. And the definition can be a little unusual, especially if you're not used to formal mathematical definitions. And so instead of giving you a typed up step-by-step definition as I did in the previous video, I'll use the same concept to guide you through. You can avoid the formal definition by just thinking of inverse cosecant this way. I have to find some arc length, the cosecant of which is radical 2. In other words, whenever you're being asked an inverse trigonometric function, you want the regular trigonometric function to equal that argument. And by definition, we have to find something in between negative pi over 2 and pi over 2. You may wonder why some of the definitions have different sort of range values here, such as one of them had 0 to pi in the previous video. That is a very interesting and very off-topic discussion that I won't get into in this video, as much as it interests me. And so we're trying to fill in the blank here. The cosecant of blank equals radical 2. Now, there are many ways to fill in this blank. There's only one way to fill it in, picking a number between negative pi over 2 and pi over 2. And just like the previous video, here's the somewhat uncomfortable bad news, or very exciting good news, depending on how your brain works. Your only strategy here, guess and check. And a complete knowledge of the unit circle. So here's my thought process. If I'm looking for the cosecant of something to equal radical 2, I might want to think of that as the sine is the reciprocal of radical 2. After all, the sine is the reciprocal of the cosecant. If I can fill in the blank of the bottom line, the sine of something is 1 over radical 2, that would be the same as filling in the blank above it. The cosecant is radical 2. Well, I'd rather think in terms of sine here, because the sine is my y-coordinate on the unit circle. That's something tangible that I can see, whereas the cosecant not so much. So my new goal is to fill in this bottom line. The sine of blank is 1 over radical 2. By the way, you may recall that 1 over radical 2 is the same as radical 2 over 2. And not that you have to do that, but that might make it seem more unit circle familiar to you, because radical 2 over 2 is the typical way to express that number. So I'm thinking of the unit circle here, and I'm thinking of points whose y-coordinate is that. Well, that number is about here. You may recall that it's approximately 0.7, just to give you a physical location to put it. And now we need to find a terminal point here that has that number as its y-coordinate. Well, there are only 2 points on the unit circle that have that y-coordinate. So if I'm going to fill in this blank, sine of blank equals radical 2 over 2, I need something that terminates at one of these 2 points. Well, there are infinitely many angles that terminate at those 2 points, so let's just go through some of them. First of all, I could guess negative 5 pi over 4. That terminates at the point on the left and does have a sine value of radical 2 over 2. However, that's not the answer to my question, because negative 5 pi over 4 is not between negative pi over 2 and pi over 2. So while that statement is correct, it doesn't meet the condition, you may see it in green here, that I need. Well, negative 7 pi over 4 terminates there, And it is true that the sign of negative 7 pi over 4 is radical 2 over 2. But again, negative 7 pi over 4 is too small and does not fall in the range negative pi over 2 to pi over 2. And so you keep guessing in this fashion until you get it. 3 pi over 4 terminates there, and it has a sign value of radical 2 over 2. But again, 3 pi over 4 is bigger than pi over 2, and therefore not in the range between negative pi over 2 and pi over 2. Now I've made 3 wrong guesses on purpose, and you may not need to make 3 wrong guesses before you make a right guess. In fact, with your deductive reasoning skills and cleverness, you'll probably get it on the first try. But I'm going to let your brain develop that skill on its own. I'm simply showing that you keep trying things until it works. Eventually, you'll try pi over 4. In fact, that may have been the first thing you tried, in which case you wouldn't have gone through 3 wrong guesses. Now, notice, not only is the sign of pi over 4 radical 2 over 2, as you'll recall from your unit circle knowledge, but specifically and importantly, pi over 4 is between negative pi over 2 and pi over 2, and therefore pi over 2 is the answer to this question, the inverse cosecant of radical 2. Before we go to the next problem, I think a comment is in order here. If you would like a more direct, mechanical, non-guess and check method to do this, you could probably find them in other YouTube videos, not made by me. But to really get that mechanical about it and procedural, you may as well just be an app. And there's no point. Your brain will not develop if you're an app. You'll just become a procedure following individual that's going to get the right answer with some kind of efficiency, but that efficiency comes at a price. If you're not willing to guess and check your way through these, as I've demonstrated here, your knowledge will be very short-lived. You'll forget it a week after you learn it. So I don't recommend more gimmicky procedural methods. With that thought in mind, let's look at one more example, the inverse tangent of negative radical 3 over 3. Here's the definition of inverse tangent. But again, because mathematical definitions can be strange sounding to the average student, let me just put it this way. If we're asked an inverse trigonometric function of negative radical 3 over 3, we want the regular non-inverse function to equal that value, and we need to fill in that blank. But the definition of tangent requires, inverse tangent, requires that we fill in that blank with something between negative pi over 2 and pi over 2. And again, if you're wondering where this definition came from, great question, long story, not part of this video. But that is the definition of inverse tangent. So now let's set about the task of finding something to fill in this blank. Well, here's the unit circle. You may recall that the tangent value contains the number radical 3 in whenever you have a multiple of pi over 6. But furthermore, let's restrict our values just in the initial thought process here to either these two or these two multiples of pi over 6. And before we get into what those are, I'm just going back to basic unit circle knowledge here. But I'm also considering the fact that the tangent of blank has to be negative. Well, the tangent can't be negative in quadrant 1, and it can't be negative in quadrant 3. Why? Because in quadrant 3, you'll notice I haven't put any guesses there. In quadrant 3, tangent being sine divided by cosine, we would have a negative divided by a negative, but that can't equal a negative. And so I've restricted my view to quadrants 2 and 4, because those are the only logical places where the tangent can equal a negative number, being that it's the y-coordinate over the x-coordinate, or sine over cosine. Now, you have to use some trial and error here. Honestly, what I would do is just compute the tangent of any angle that terminates in any of these 4 places. We'll quickly eliminate 2 of them, just from your unit circle knowledge, because in those 2 that just erased, the tangent is radical 3, not radical 3 over 3. Anyways, if you're a little confused as to how I've eliminated it down to these 2 points, and you're not sure about the logic, that's okay. Just consider all 16 points of interest on the unit circle, and you'll discover that these two are the only two that have a tangent of negative radical 3/3. So at this point, I've got to fill in the blank. Well, here's a wrong way to fill it in, but let's analyze it. Negative 7 pi/6 terminates here. And it is true that the tangent of that is negative radical 3/3. However, negative 7 pi/6 is not between negative pi/2 and pi/2. And therefore, I'm going to discard that option. Now again, I'm going to make a few wrong choices before I get to my right choice to demonstrate the spirit of guess and check. You may not have to make several wrong guesses, or you may. 11 pi/6 terminates in quadrant 4. And the tangent of 11 pi/6 is in fact negative radical 3/3. But 11 pi/6 is not the answer here because we need something between negative pi/2 and pi/2. Five pi/6 terminates here, and it's true that the tangent of 5 pi/6 is the value we need, but 5 pi/6, again, not between negative pi/2 and pi/2. So you keep trying things until you get something between negative pi/2 and pi/2. Eventually, with a combination of luck and cleverness, you'll stumble across negative pi/6. Because negative pi/6 terminates there, and its tangent is the correct value we need, and, importantly, negative pi/6 is between negative pi/2 and pi/2. And therefore, the answer to the question we seek is negative pi/6. And that completes the second of 4 videos.